Danse everyone, I'm Dallas Flipwapash, and we're with Create to Learn Round 2. This is the fourth and final part of a series aimed towards prototyping in augmented reality. We're using the Unity and Vuforia combo, and for this episode we're focused on finishing our augmented reality prototype. By finishing our virtual button, triggering an animation with it, adding buttons that we can click on with our smartphone screen, and then building it to Android phones. So we're almost done, and we couldn't have gotten here alone. These videos are made for the Create to Learn initiative between Taking It Global and Imaginative. Follow Create to Learn's Instagram or the hashtag Create2Learn to find more series that teach youth digital skills. That would be super awesome because we all benefit when we're all just a little bit more creative. This series is produced in Brandon, Manitoba on Treaty 2 territory. The land here is the traditional lands of the Cree, Oji-Cree, Anishinaabe, Dakota, and Dene peoples. It's also the homeland of the Métis Nation, and this treaty was made in 1871. You can learn even more by visiting trcm.ca. Alright, let's get this finished. So last time we made animations and set them up in the animator to transition between each other. We're using a trigger that we now have to call through code somehow. Select the virtual button game object in the scene hierarchy, and then in the inspector, click on Add Component. When adding a component, you can type the name of the component you want, but here we're using a custom script, a script with code. We can name this script whatever we want. I named my script Bug Button, so type the name for your script. This could be any name you'd like, but it might be best to keep it relevant to buttons some way. This script will be added as a component to your game object, so double click on your script's name, and Visual Studio or MonoDevelop will open up. Visual Studio and MonoDevelop are used to write code within, and they're handy for finding errors within your code. So I've written some code here already. We'll go through it line by line, but first I'll show you what a default script looks like when you create one. So there's some obvious differences that we'll have to make here. The top 3 lines start with the word using. This basically tells Unity, hey, I want to access these libraries so I can quote and use specific commands. You'll notice I'm using Unity Engine for basic game object commands, Unity Engine.events for events related to buttons when they're pressed or let go, and I'm also using Vuforia as it has its own commands related to AR. Notice how all these lines end with a semicolon. The semicolon is used to be at the end of our line, kind of like a period at the end of a sentence in a journal. It helps Unity understand when a line is done. So now I have a public class bug button, mono behavior. The word public class means I could write something in this code and have it be accessible from another script, aka class, separate from this one. Bug button is the name of the script and follows the mono behavior structure of writing commands. So after that is a curly brace. This curly brace is one of 2, and everything in between these 2 curly braces belongs to this class. This ownership and level of code is conveyed through indentations through the code, as you'll soon see. Text will progressively become further away from the starting wall, the deeper the level of code becomes. Next, I have public game object BTN, which is short for button. What I've written here is called a reference, and so I'll have to link this reference to something, and that something has to be a game object by nature. For example, I couldn't use a photo here because it is not a game object, but a file. This is where I'll be putting my virtual button game object because there's some information on that button that we need for the sake of code. I use BTN for short so that I don't need to write game object every time. I'll write BTN instead to save some time. So this button has components, which is what I'm trying to access in the start function below. Void start. So void needs to be written so Unity can understand the purpose of this function. Void essentially means that when the function finishes, nothing more is expected after that. It's not returning anything. Start is a command that comes straight from the Unity's library and is used at the first frame when we run our app. Immediately, I want some stuff to happen. So I want access to 2 tracking related functions. So I use codename BTN and then use a period to access BTN's commands or properties. I know that a command every game object has is getComponent. Components come in various different types, and this type is declared using triangle braces. Inside of them, I write virtual button behavior, because that's the name of a component. Then, I use a set of regular braces to have this function go off. Once it does, I can then access that component's commands or properties, so I use the period again. The period is called the initializer and allows access to something's commands, basically. Through research, I found that Vuforia uses the command register on button pressed and register on button released. Inside of both of these commands is the name of the function I want, on button pressed and on button released. After these two commands, the start function ends, as indicated with the ending curly brace. We then move on to public void on button pressed, the same name that we got in the start function. Notice how there's conditions put inside of these braces at this time. This wasn't the case in the start function, as we can see, so why is it happening here? Well, the information of tracking with Vuforia is sort of stored within this virtual button behavior component. I believe Vuforia uses this function every frame to see if we've touched the button or not. Then, after that, it's given a code name, VB, in case we wanted that information. But we don't, so there's no need to really worry about it. It's just convention to give things code names in this case. So after that, we see another set of curly braces, indicating the full extent of this function. Everything inside the braces is all this function can do, where it begins and where it ends. For now, I've written a debugging statement just to know if whether or not this is actually working. So legit. I totally understand if this is your first time reading code that it could be a lot to take in, so if you're not too worried about the details, consider taking some time to write this script similar to how I have here. And be keen on putting semicolons and braces in their proper location. Alrighty, so let's get the button interacting with our animator. Let's call that trigger that we made in the last episode. I'm going to write public animator AR anim, because I need to reference the animator that exists on my pencil box. Since I already know this button works, I'm going to remove the debug statement that I've written on the button press function. I'm going to replace it with a reference to my AR anim, using a period to access its commands, and using its set trigger function. The set trigger function uses braces, and inside of them, we can use quotation marks. Using quotation marks creates what are called strings, which is code that can be written like a real person talking, like I am. In the last episode, I made a trigger, and I called it race with a capital R. So I'll type it exactly as it shows in the animator, so that when my code commands the animator to do something with it, the animator will know who I'm talking about. And that's really all I need. So I'll put a semicolon. For more experienced coders, you can also use the onButtonReleased function to make an action happen when your hand leaves the button instead of when it comes in. I'll run my app to test, and I notice it doesn't work because I forgot to click and drag my reference for the animator. I'll probably have to do the same for my virtual button. I'll stop this run, and in the scene hierarchy, I'll select my virtual button. Yep, I can see that AR anim is blank within my bug button script. Since the pencil box is the parent animating its children, I know that pencil box has the animator, so I'll click and drag the pencil box game object over to this blank bar on my bug button script. The script will search for an animator from this game object, and if it has one, we'll link to that. I'll test again, and it works. The animation looks a bit crusty because this is before I had done all that work in making the virtual buttons work in the first place. So I'll take some time to fix it up just to catch up with you. The last two things we'll do now is make on-screen buttons that will click using the screen of our phone, and then build this application to our phone. So what do I want these buttons to do? I remember earlier from that journal thing that I wrote, I want these buttons to cheer for individual bugs in the scene. I'll convey that cheering through another particle system. So right-click in the scene hierarchy, and then select Effects, then Particle System. The main characteristics of my particle system is that it doesn't loop, so instead it'll be more of a burst. The max particles will be reduced to 70, and in the emission tab, my rate over time will be 400, so that max can be achieved rather quickly. Then, I'll change the colors to my own preference. Aside from that, I'll also change the size over lifetime. I'm happy with how this looks, so I'm going to be reusing this particle effect multiple times. So I'll need a way to copy it. The way I can do this is by clicking and dragging the particle system game object into my project window. This will create a prefab. And so prefabs are a copied instance of a game object that you can reuse over and over again. The benefit of using them is that when you change the original prefab, all of its used instances will change as well. For example, picture the coin from Super Mario Bros. Imagine Miyamoto didn't like the sound the coins made when you touched them. Instead of changing the sound for each individual coin, he could go straight to the prefab, change the prefab, and then all of the instances of the coins would change as well. So we saved himself some time, because Miyamoto is a genius. Let's make a button that spawns this prefab on one of my bugs. Right-click in the scene hierarchy, UI, which is short for user interface, and then button. This will create a button game object, which is the child of a new canvas game object as well. The canvas is responsible for displaying user interface elements, and the button is just one of those elements. The canvas is sort of superimposed onto the app. To show what that looks like, I'll click and drag the game window to the right side of the scene window so that I can see both running at the same time. We can see our button is super small on the final product. We'll fix that, but first, make sure the button game object is highlighted. Then, in the inspector, you should see a rectangle transform. Click on this box so that we'll be able to change the anchor point for the button. The anchor point is currently placed at the center of the button, which makes it prone to not being fully visible. Instead, hold Alt and Shift on your keyboard and press the box located at the bottom left corner, or any corner you'd like. This will reset the button's anchor point and its position at the same time. So now, the button is glued to this corner. The button has a child too to store its text. We can change the button's text by going to this child and typing something else in the inspector. With that done, let's go back to the canvas and change the canvas scaler. Set the UI scale mode to scale with screen size. This will make the button scale a bit more reliably on someone's screen. You'll need to tweak these numbers according to the size of your phone. And with that done, we'll head back to our button game object and scroll down in the inspector to find the onClick function. Essentially, we can make something happen here when we press our button. And to save time and space, I'm going to write another script that just has one function. But what that function does will change depending on the number we give it. So if we give it 1, it'll do something, and if we give it 4, it'll do something else. Press the plus symbol near that bottom right corner of this area. We can see that we can click and drag an object into there. I currently don't have a script, so I'm going to add one to my canvas game object. Click on your canvas, go to Add Component, and type any name for a script you'd like. Once this script is added as a component, double-click its name to open MonoDevelop or Visual Studio. I'm going to create an array of game objects, so more than one, and give them the code name creatures. Arrays are made with square braces, and later in Unity we'll be clicking and dragging all the bugs here. Then I'll make a reference to the particle system prefab and give it a code name. Those are all the references I need for this. And then I'll make a function to spawn the particles at wherever each bug is located at any given time. I'll write public void cheer for bug. I'm using public so that this function is usable by my button. I'll then use an integer to store a number that my button gives us. I'll codename this number bug to cheer. So to recap, we don't have a number just yet. We'll be given a number from our smartphone's button, and based on that number, the particle will spawn somewhere. Spawning those particles looks like this. I'm storing this spawn event inside of a variable, which I codename E for effect. I set E to the result of an instantiation. Instantiate is the Unity command used to spawn something from out of nowhere. This command needs some things. Something to spawn, a place to spawn, and a rotation for that spawn to be born at. So E will spawn the burst effect at the location of one of our bugs. This bug is picked out from the array we created using square braces, then the number we got from our button. Once we have that bug selected, we'll find its location using transform.position and setting its rotation to its default rotation as a prefab using quaternion.identity. So I don't want this particle to exist forever. I'm going to use a destroy command to destroy it basically after like 2 seconds. Awesome. So this is all we're going to need. Back in Unity, I'll select the canvas game object since that's where my new script is. I'll find it listed in the inspector and see that burst effect is blank. So from the project window, I'll click and drag burst effect into there. Then for the creatures, I'll click on this triangle right beside the name. I have 5 bugs, so I'll type 5 here to establish the size of my array. And now I'm given 5 blank bars to click and drag my 5 bugs right into. With that set, I'll click on my button and go back to the on-click area within the inspector. I'll click and drag the canvas into here since that's where my script is. Then in the drop-down menu in the upper right, I'll highlight the name of the script I made and find the public function that I made. Since my function is asking for an integer, I can now give one here. I'll leave this as 0. Arrays start at 0 for some reason, so the highest our buttons are going to get is 4 if there's like 5 different areas that you're spawning. With this made, all I need to do is make 4 more copies of this button, because I have 5 bugs in total, and change the integer set for each of these buttons. I'll test this now. And since I'm not using my phone right now, I can instead click on my computer screen using my mouse to use these buttons. So awesome, I can see that that works just fine. So you can totally experiment even further with this prototype, but for now, I want to be able to show you how to build this to your smartphone. On your smartphone, enable developer mode. To do this, you're going to have to go to your settings app, then scroll down to the about phone section. Once you're there, go to software information, then click on your build number around 10 times. Once that's done, developer mode will be enabled. Then go back to where you found software information. You should see developer options listed here now. Scroll down until you can see USB debugging and turn that option on. Now finally, get a USB Type-C cord connected from your phone to your computer. Just to make sure, open another Unity Hub window and go to the Installs section. Click on 2020.1 and add a module using these 3 dots. Now ensure that you have Android build support, along with its Android SDK and NDK tools, along with the OpenJDK. These are software development libraries or kits that allow you to build locally to your phone, and by locally, I mean that this app will be only on your phone and not the internet. So now, in the top left corner of Unity, go to File, then Build Settings. The build window will open. You may see many scenes listed here, depending on packages downloaded, but you can highlight these extra scenes and delete them with the delete key on your keyboard. The scene that we've been making this prototype in has been the sample scene. Be sure not to rename this scene, as we'll probably lose it that way. And your platform, or the place you're building this app to, might be PC, Mac, and Linux, but we'll want to switch it to Android. So from this list located at the bottom left of this window, click on Android. Then, in the bottom right corner, select Switch Platform. After this, Unity will take some time to rework its files to enable them to work in an Android environment. In my case, it took several minutes. So I have to set up my phone using Run Device. I'll know that my phone is properly selected because it shows up with an acronym and a series of numbers. With that selected, I then click Build and Run. I'll be prompted to store my build somewhere in my computer. And typically, I make a separate folder and rename it to Builds. Then I go inside of that folder and build there. Unity will take some time to build this app that we've made over the span of 4 episodes. And eventually, it should automatically show up on your phone. And using your phone's camera, you can aim it towards the AR trigger that you set up, and it should pop up. And if you cover it with your hand, the virtual button should work, along with the buttons that you've placed on the canvas. So that's awesome! We made our first augmented reality prototype in Unity. Congrats, fam, you did it. You're amazing. We did it together. So that was awesome. That's really all I gotta say. I really want to thank the Create to Learn initiative here, because it's been really good in allowing, you know, creators like us to make these sort of tutorials for people to learn how to be more creative in terms of a digital sense. I think with all that learning out of the way, I'm gonna go take a break. I hope you enjoyed making this AR prototype, and I will see you later. Have a good one.